Hello friends, welcome. Friends, today we are going to talk about level of detail expression in Tableau. Now friends, whoever is expert in Tableau, they might be aware of this level of detail expression. But for a beginner, this level of detail can become extremely confusing. Now in this video, I will make an attempt to simplify this as much as possible using examples and using other tools to explain what level of detail accomplishes, because sometimes if you only work in Tableau and don't show parallels of how the same task can be achieved using other tools, then the concepts does not become very clear. There are different videos which will be available in the YouTube to explain level of detail. I'm not going to follow the conventional approach. I'm going to use a very unconventional approach in this video, and it will become very clear as I progress in this video. Now, before I start working and explaining this concept, what I'm going to do is I'm going to show you the database which I am going to use for this purpose. So this is the data. Now, what is this data all about? This data has got 4 dimensions. So let's look at the dimensions that this data is categorized on. One is date, then we have circle, then we have category, and then we have operator. And these 4 dimensions are associated with a single subscriber value. So that is how this data has been categorized. So when you talk about level of detail from a conceptual point of view, what you can do, you can aggregate these 4 dimensions into one single index, like this date value 31 March 2024 plus AP plus Warline plus Bharti can be aggregated as one single index. All these 4 values of this dimension, of these 4 dimensions, can be aggregated as one single index. And when you do that, that index, which is uniquely identifiable, will have one single subscriber value associated. This is how level of detail is defined. So look at this in this way, otherwise this will become very confusing. Whenever you talk about level of detail, people get confused. The level of detail is that if you have values in the dimension which you can uniquely identify, because you may not be able to uniquely identify. Let's say if I aggregate these 2 dimensions, Warline and Bharti, these are not going to be uniquely identified because it is repeating. But if I add circle and date on these 2 dimensions, right, then it becomes uniquely identified. That is the lowest level of granularity of this data. So that is called the level of detail. Now you may choose not to have the subscriber calculated at the finest level of detail. You may choose to have the subscriber getting calculated in the date level of detail or date plus circle level of detail. It depends upon your choice. So when you do that, then this subscriber value will get aggregated using an aggregated function, typically sum, so that value will be represented to the level of granularity that you choose for doing the calculation. So let's go to the Tableau sheet. It will become much more clearer. So what I have done here is that I actually have used a very simple database to demonstrate this level of detail. So I have I'll put these values in the view. So in these dimensions in the view, so I have put date dimension in the view. So I'll take exact value of date, and then I'm going to do discrete. Then after that I'm going to put circle in the view. So now it will become like that, and then I'm going to put category also in the view. Okay. So I'm not going to put operators in the view because there is only one operator, because otherwise the database was getting very, very bulky and my computer was getting slow. Therefore I took out the operator from the calculations. Now I can put subscriber here as text, as values. So now if you see the subscriber values, what you can see here are individually identified because of these dimensions which are in the view. So there are dimensions and there are measure. Subscriber is measure, and date, category and circle is the dimension. So these 3 dimensions uniquely identifies one particular subscriber. So that is the level of detail. Now if I take category out of the view, then what happens? happens? Then we have only two dimensions, and this value, which was uniquely categorized based on wordline and wordless, because wordline and wordless is the are the values in the category dimensions. So that those are now getting aggregated at one single value, right? So you see this? These were all different. AP 309 58572 250 880. These are going to get added up for AP. Just look at AP, and this is going to be now the level of detail, because now it becomes 312094552. Okay, so this is how so in Tableau, whatever you see in the view is the level of detail. That is a simple concept. Now, what is the level of detail calculation? There are three different types of level of detail calculation. One is fixed, another is exclude, another is include. I'm not going to go with you to the to other two, because it will make the video very complex. So we are going to talk about only fixed. So what I've done is that I have created a calculated field of fixed, where I have taken only two dimensions, date and circle, and then I'm aggregating that the subscriber to these, pointing to these dimensions. So what is this going to accomplish? Let's understand this first. This will ensure that it has got nothing to do with the view. View may change, but these, whenever you are putting this on the view, then what will happen is that the level of detail values are going to get aggregated. This calculated field, when I put in the view, then the level of details are going to get aggregated to only date and circle dimensions only. It will ignore the other dimensions, whatever is there in the view. For example, category dimension, let me just put category dimension, and I'm going to show you. I'm going to put category dimension in the view, and then I'm going to bring the LOD dimension, LOD fixed on the view also, right, in the measure. Then you will see that, you'll see here so you see that subscriber numbers 309 58 572, and then down below here 250 880, both are uniquely identified because subscriber is below, and then the number below that is an aggregated number which I showed you when I took category out of the view, which is 312094552, and here also 312094552, right? Now there is one more major property of fixed level of detail calculation. Let's say if I put category in filters, and I'll try to filter, right, only wireless, right, one of the category, it will remain unaffected. You'll see that the number will remain unaffected because the whatever dimensions are there in the view, the fixed calculation does not get affected by the dimensions that are in the view. See, it is 312094552, same value is there, but the other dimension, category got removed from the view because I've used a filter here. Now I can do the same thing for circle filter. Let's say if I do circle level filters also, because it is fixed to the circle level. So let's say if I removed all and I just use 2 or 3, which will make the view a little smaller, then you will see that though I have used a filter circle and I am only choosing AP, Maharashtra, AP, Assam and Bihar, you will see that these numbers, aggregation at the date and the circle level remain the same. Right? Now, how do you relate this to the Python-based calculation? Let's do that so that we understand what is the use and how we can use this, and what kind of results that we will be able to accomplish. So what I've done is just to demonstrate that what actually it means. I'm using a Python Jupyter lab sheet, and I'm going to load this data which I have loaded in Tableau. So this is how the database will look like, right? You see that? The same thing, which you have date, circle, category, operator and subscriber. Then what I'm doing is I'm using a group by function. Now if you see here, I'm using a group by function, just like I did the same LOD function here. If I go to the Tableau dashboard and I show you that how the fixed level calculation looks, here also I did the same thing, which is date, circle and sum, right, of subscriber. Here also in Python I am basically using the same calculation. DF group by date circle, and then I am summing the subscriber column, right, and pointing to these two dimension. Then I am doing two frame and reset index just to basically convert this series data, because this will ultimately there will be a series, it will not be a data frame, it will be a series data which have to be converted into data frame, and then I am resetting index so that the index will now will transform to column. So I'll show you how it basically will look now. If I run this, and I am basically going to enter a cell here, and then I will put this here to show you that how this looks. Now you see, I have date here, I have circle here, and with subscriber here, and this is exactly what you see here, right? Look at this. This is of the same now, 31209,542. Let me remove subscriber from the view so that it becomes a little clearer. So you see here, you have got how many? 3 circles here. So if I put circles also, I'll take out from the view, the filter I'll take out. Then you will see that for a particular date, I have one circle, 31209,452, and it is almost similar. It is similar to this. You see, 31209,452. Similarly, Assam is 9035945. Here also, if I go here in this Tableau sheet, you will find that it is 9035945. So level of detail in Tableau when you are doing the fixed calculation is equivalent to the group by function. Group by function, where you are grouping. When you are doing grouping, what you are doing is you are basically elevating the level of detail from these 4 dimension to only 2 dimension and using an aggregation sum. That's all you are doing, right? There is nothing great about it. Now, what is the use of this? Why are we going to use level of detail? Now, the reason we are going to use level of detail is sometimes you have to work with the data. And when you are working in the data, maybe you want to calculate percentage, right? Let's say if you want to do a calculation of percentage, means let's say that for AP, what is the percentage of wireless subscriber and what is the percentage of wireline subscriber. For that, you need the sum of wireline and wireless subscriber together, and that's why you will use a group by function like this. So when I have calculated group by function, I have stored this in this data frame which is named as DF LOD fixed 1, right? Now what I am going to do is that the main data frame, which looks like this, date, circle, category, operator and subscriber, I am going to merge this same data frame which you saw here, which is the fundamental, the basic data frame which I have loaded, and then I have transformed this database using a group by. So I am going to merge this using PD merge DF, the same data frame which I stored here, and then on date and circle. So I'm basically doing what? I'm linking these two data frame on these 2 dimensions, date and circle here. And once I do that, when I do the merging here, it's a simple merge, there's nothing great about it. Then I'm going to show you how the data frame is going to look like. Let's say I put DF1, and you'll see that the data frame is now going to get merged here. So I've got 2 subscriber value, subscriber X and subscriber Y, depending, because there are two subscribers. This is one subscriber is here, another subscriber is here. Now what will happen is that this subscriber, which is 31209,452, will get repeated, because there will be 2 category, wireless and wireline, and then the operator is same, it does not matter. And then you will find that for wireless in AP, Bharti has got a subscriber value of 309,58572, and the total subscriber which you add, if you add the wireline subscriber, it comes out to be 31209,452. Now because these are getting repeated across both wireline and wireless, and the subscriber values are uniquely extracted out, it becomes very easy for me to do a percentage calculation, which is a simple vectorial division of the 2 columns. So when I do this, then I create another column called DF%, and you see how it is going to look like, right? So here, if I just extract this out and do DF1, then you'll see that there is one more column which has been created, which is a percentage. So this is a very simple way of calculating percentage, which will become extremely difficult if you are not going to do group by and aggregate the level of detail to a higher level to perform this task. Similarly, in Tableau, the same thing is done. So if you look at this, so what I have done is, this is the level of detail which I showed you, right? Fixed, date, circle and sub, right? Which I already showed you in the group, in the view, which is remaining fixed here. Then what I am going to be doing, I put subscriber also in the view to show you both the values here. So like, because I have taken wireline out of the view, so I can put wireline also. Let's do the following. Let me just make this table a little smaller so that it is visibly easy to handle. Otherwise it becomes so difficult to handle this. So I'm going to use only 4 circles, okay? So, and then I'm going to use both the category. Let me just take the category out of the filter. So I've got wireless and wireline, both the categories are there. Now the top is the LOD fixed. What is LOD fixed? The top is LOD fixed is this is the data frame which I showed you earlier. The LOD fixed, the subscriber data frame, the date, circle and subscriber, right? 3120945 for AP. So if I go here, you will find 3120945 for AP, right? Which is the top, and the bottom is the wireless subscriber for AP, which is the same AP. If you see Andhra Pradesh, there are 2 values. The top is let me just interchange this. It will become easy, right? So subscriber goes on top. Let me just put it again. Subscriber goes on top. Let's put here it is. Subscriber goes on top, and the aggregated value for both the wireline and wireless is in bottom. Similarly, here you also see that it is in the bottom, 3120945 and then the wireline subscriber, which is 250880, is shown on top. Now this is getting repeated across the table. Now since this is getting repeated across the table for both these dimensions, wireless and wireline, you can simply do a division, which is not possible otherwise, which I showed you. If you didn't merge those rows table in Python, you could not have done it. So what I've done is that I've calculated the percentage here. You see, it is simple, division. Subscriber divided by LOD fixed. Now if I put this in the view, right? If I put this in the view, you will see that the same percentage which you saw in the Python table, you see 99.02% and 0.08% for AP, right? Here you see the same thing here. See, where is the table down below? Where I calculated the percentage. Here 99.20 and 0.08%. So this is the analogy across both these 2 different tools. One is Tableau, another is Python. Now you may choose to not to use a Tableau if it is too confusing for you. You may basically go with Python and create this database and directly feed into Tableau rather than basically doing all this calculation. But sometimes it becomes difficult to do all these calculations in the fundamental data, because sometimes the data is not in your control. It is coming through an API feed. You have to store it in your computer, process it. It is better to work directly on Tableau. And that's why if I take now subscriber from out of the view, LOD out of the view, then you see that these numbers are going to show up. See, 99.02, 0.8%, then Assam is 100%, it is 0% because there was no wireline subscriber. Now if you go here, you'll find that as time progresses, Assam has now got some wireline subscribers also, and there is these are getting added up. So this is how simple calculations can be done in Tableau using level of detail. The advantage of level of detail is it is not getting impacted by dimension filter. So that is the main advantage. So even if you take out the dimension filter or you include the dimension filter, it is not getting affected, and that's why the view is not getting altered. So you have full control over the view, and because you have got full control of the view, therefore you can calculate these percentage. Otherwise it becomes very difficult to calculate these percentage. You have to use then Python to do that job. Let me just make this a little bit smaller, otherwise you will not be able to see what is going on. So let's do this. Okay, I think the formatting has to change. I'll just make it a little smaller. Yeah. So you see, formatting has to change. So here it is. So these numbers are actually becoming a little higher, bigger. So what I'm going to do is that I'm going to do a date filter also here on top of it. I'll remove some of the dates. I'll just take out some few years from the view so that it becomes easy. So I'll just take 2024, or maybe I'll just choose 2021. so that it becomes it shrinks a little bit and it is easy to see. And then I can basically enhance the font now. So I'll make the font a little bigger so that you can see. I'll make it 9, right? So now you can see this, right? So you have got 99.2.08 like this. So this is how you can basically use level of detail. There are various applications of level of detail. Internet is flooded with these kind of information. But to understand the fundamental, what is level of detail, you need to basically look at these kind of way of, looking at this whole problem, rather than basically going into, and getting confused about this. If you know that what level of detail means and how it can be elevated to a higher level to do various kind of calculation, then the things will become very clear in your mind. I had one more example, example 2. So what I have done is that instead of using here date and circle, I am using date and category. You see, date and category, and I am basically using the same thing. So if I run this, you'll see that, and I'll show you. I'll do it in Tableau also, and I'm going to show you how the data frame looks now. So when I'm doing date and category, and I'm basically doing aggregation on data, because I have removed now circle here. So I've got only wireless and wireline here, right? An operator is only one, so therefore does not matter. So I've got this, and then I'm merging this to the main data frame on date and category, right? Again, the same thing will show up. So if you look at the DF2, how it looks, here you'll see that I have got the two different subscriber values which are showing up, pointing to wireless and wireline. Now for wireless and wireline, these two numbers will be different because these are the numbers for operators, Bharti, and the total subscriber. If you add this together, 30958,572. If you add this together, both these numbers together, this is going to become. So actually, it is not both. These two numbers are not getting added together. What is happening is that because I have taken circle out of the level of detail, so it is basically now it is getting added up across category. So the wireless category has got one single sum. Similarly, the wireline category has got one single sum. So what will happen is then when you calculate the percentage, so it will basically tell you that if you take the wireless as the base, what is the percentage for in AP for Bharti, and what is the percentage for AP for Bharti for Assam, like that. Similarly, if you take wireline as the base, because this is the wireline sum, it will give you the percentage for various circles for Bharti for various date for wireline subscribers. So that's how. So if I do the calculation, you will see here the same thing is going to happen. So here, if I do the calculation, you'll find that the percentage numbers are being shown up here. I can do the same thing in Tableau. Let me show you how it can be done very quickly. So I'm going to change this level of detail value, and instead of using circle, I'm going to use category here, right? So let me just do category. And when I do category, you see that the same numbers are going to show up here, right? Here you see AP is 9% for 2021, right? And because so AP is 9%. Let me see what the number they came out. Yeah, you see 9%. Because if I remove the, I'll basically do a little bit of, because this is one single decimal place. If I change the formatting here, and I basically do, see, you see that 8.98%. The same thing, 8.98%. So friends, probably you have understood how the level of details work, and there are various capabilities or applications of level of detail. I don't have to go through those because those are available. You can go and look at internet, and you can look at YouTube videos. But what is important is to understand the fundamental concept, which is extremely important. So you've got two options. Either you use Python and do the calculation right at the Python level and feed it to Tableau if you are confused with Tableau. It's easy to do in Python because it is much more intuitive. But if you want to do it in Tableau, you need to understand, because sometimes it is not possible to do in the fundamental database because the data may be coming through a stream of data and directly getting fed into Tableau, which is not possible. Then you cannot do the calculation. For that, you have to use Tableau to do the calculation. Both the flexibilities are there. and I think you probably have understood how this level of detail works and what are the utilities of level of detail. Okay, so friends, thank you very much for your time. I'll come back to you with a new video next time. Maybe fixed and fixed we have already talked about. Maybe include and exclude depending upon what utility, whether it will make any sense for me to even talk about, because people have already made hundreds of videos on this subject. I don't want to repeat what other people have said. The reason I did this video is I wanted to show you that how it can be worked in Python, and it accomplishes the same thing when you are doing it in Tableau. That's the whole purpose of this video. Thank you very much, friends, for listening, and I'll come back to you with a new video next time.